The semiconductor world, man, I swear it's moving at warp speed. It seems like just when you think they can't possibly make transistors any smaller or chips any more powerful, something new comes along. And speaking of things coming along, we've got to talk about Saqp, this company out of China that's making some serious waves.
Yeah, they're pretty impressive, especially given they've only been around for a few years.
Right. Founded in 2021, based in Shenzhen, Guangdong. But already they've got this really wide focus. Research and development, of course, but also production and sales. Not just of the semiconductor equipment itself, but the components that go into it. And even branching out further into electronic manufacturing devices in a more general sense.
Exactly. So not content with just being a niche player, they're clearly aiming to establish themselves across the board. And one thing that's particularly interesting about Saqp is their close connection with Huawei technologies.
Ah, yeah. Huawei. Big player.
Huge. And Saqp has a specifically strong relationship with Huawei's internal research division, the 2012 lab. We're not just talking about some loose partnership here. It's a pretty deep collaboration.
Okay.
There's been an exchange of staff between the two organizations, and they've even shared patents.
Wow. Exchanging staff and patents. That goes way beyond your typical partnership. So what kind of technologies have actually been involved in this back and forth between Saqp and Huawei?
Well, one example that stands out is soundproofing technology, specifically for electronic machinery. You might not think of that as a core element of semiconductor manufacturing, but when you're dealing with these highly sophisticated fabrication facilities, noise control becomes a major factor.
Makes sense, yeah. A controlled environment is critical for that level of precision.
Absolutely. And there's also been collaboration on data center designs, which is obviously a crucial area for any tech company these days, especially one with the ambitions of Huawei.
So it's not just semiconductors. There's this broader connection in terms of infrastructure and technology development.
Right. But when it comes to the semiconductor side of things, the relationship with Huawei goes even further. And see, Saqp also acts as a sort of intermediary, a link between Huawei and other companies in the semiconductor supply chain.
A facilitator, essentially, helping to build out a more interconnected network.
Exactly. And in addition to these external collaborations, Saqp also has a bunch of subsidiaries that are actively involved in some really crucial parts of the semiconductor manufacturing process.
They're not just relying on partners, they're building their own expertise in-house.
Right. So, for instance, they have subsidiaries involved in producing photoresist, which is that essential light-sensitive material used in photolithography.
Okay, right, photolithography.
Yeah.
The process of essentially printing those incredibly intricate circuit patterns onto the silicon wafers.
Exactly. And on top of the photoresist production, Saqp also has subsidiaries that are directly engaged in photolithography itself and even in manufacturing the equipment used for those processes.
So they've got this vertical integration strategy going on, covering several key steps in the manufacturing chain.
And that gives them a lot of control, the ability to really fine-tune things and potentially drive innovation at each stage.
And speaking of innovation, that brings us to one of Saqp's most notable achievements so far, and this is a big one. Self-aligned quadruple patterning, or SAQP as it's known in the industry. Now, for our listeners who are maybe familiar with the basics of chip manufacturing but haven't delved into this specific technique, could you break down what SAQP is and why it's causing such a stir?
Sure. So you know how in chip manufacturing, the goal is to squeeze more and more transistors onto a single chip. And that means the individual features, the lines, and components on those chips have to get smaller and smaller.
Yeah, Moore's law and all that.
Exactly. So traditionally, when you're talking about creating features at the really small scale, like 5 nanometers or even smaller, you need extremely advanced lithography equipment. And for the most part, that's meant relying on EUV lithography, extreme ultraviolet.
EUV, the big kahuna of lithography,
Right.
but also incredibly complex and expensive. Not to mention the geopolitical factors tied to access to that technology.
Exactly. It's a sensitive area. And this is where SAQP comes in. It's a way to push the limits of existing deep ultraviolet or DUV lithography to achieve smaller feature sizes without needing to rely on EUV.
Okay, so using a more widely available technology, potentially at lower cost, to essentially achieve similar results to EUV.
Precisely. Now, it's not like SAQP magically turns DUV into EUV. It's a more nuanced process. Basically, SAQP is a form of multiple patterning. In standard DUV lithography, there's a limit to how close together you can draw lines on the wafer. SAQP is a clever way to create multiple lines within that same limited space, effectively multiplying the pattern density.
So it's not about changing the fundamental capabilities of the DUV light source itself. It's about using a series of steps to refine and multiply the patterns that you can create with it.
Right. Think of it like this. You start with a basic pattern, which we'll call the core, created using standard DUV lithography. Then a thin layer of material, called a spacer, is deposited over that entire core pattern.
So you've got this blanket layer of spacer material covering the initial pattern.
Yep. And then comes an etching process, which selectively removes some of the spacer material. What's left behind are these thin lines of spacer along the sidewalls of the original core pattern.
So the original pattern is essentially acting as a mask, defining where the spacer material remains after the etch.
Exactly. Then the original core pattern itself is removed, and what you're left with is a pattern that's been doubled in density because you now have lines where the original core pattern was and also lines where the spacer material remained. And that's what's known as self-aligned double patterning, or SADP.
Right, so SADP gets you to double the density.
Yeah.
And I'm guessing to get to quadruple, you repeat that basic process.
You got it. Another layer of spacer material is deposited, this time conforming to the existing doubled pattern created in the SADP step. Then another etching process removes some of this new spacer material, again leaving behind sidewall spacers. And this second round of deposition and etching gives you a pattern that's roughly 4 times the density of the original DUV pattern.
Clever. So it's this iterative sequential process of using spacers and etching to essentially refine the pattern with each step. And I can see how the self-aligned aspect is important.
It's crucial because each new pattern is defined based on the previous one. It inherently reduces what are called overlay errors. That's where things don't line up perfectly as you go through these multiple patterning steps. So the self-alignment helps to maintain the precision needed for creating these incredibly small features.
And we know that Saqp was granted a patent for their specific SAQP technology in late 2023. What makes their approach unique? What's the significance of that patent?
Well, the patent specifically covers their method for using SAQP to achieve the kind of feature sizes and technical thresholds that are typically associated with the 5-nanometer process node.
Which, as we discussed earlier, is the domain that's usually associated with EUV lithography.
Right. So it's a significant step because it suggests that Saqp has found a way, using more widely available DUV technology and their patented SAQP process, to potentially produce chips with similar levels of miniaturization to what's possible with EUV.
Potentially disrupting the landscape a bit, offering an alternative path for those who might not have access to EUV or looking to reduce manufacturing costs.
Exactly. And of course, this all ties into the buzz around Huawei's Mate 60 Pro smartphone that was released in 2024. That phone reportedly contained a 7-nanometer chip, which was pretty surprising at the time given the restrictions on Huawei's access to EUV equipment.
Yeah, a lot of people speculated that advancements in DUV-based patterning techniques like Saqp's SAQP were probably a key enabler for Huawei to be able to produce a chip at that level of miniaturization, despite not having easy access to EUV.
Right, and while there haven't been any official confirmations of Saqp's direct involvement, the timing and the technical capabilities definitely line up. It's a pretty reasonable assumption.
And then moving into 2025, Saqp really stepped onto the global stage in a big way with their presence at SEMICON China in Shanghai in March. It wasn't just a research presentation, they really came out swinging.
Oh yes, SEMICON China 2025 was a big moment for them. They unveiled a whole suite of semiconductor manufacturing tools covering a wide range of processes. Etching equipment, which is used to selectively remove material from the wafers to create the circuit patterns. Deposition equipment for adding thin layers of various materials onto the wafers. Optical metrology tools for precise measurement and inspection. And even a range of other inspection and testing equipment.
So it wasn't just about one breakthrough technology. They showed up with a pretty comprehensive portfolio, signaling their intent to be a major player in the equipment space.
Yeah, it was a statement. And it really positions them as a potential competitor to the long-established giants in the industry like ASML, Applied Materials, Tokyo Electron, those companies that have dominated the semiconductor equipment market for years.
So a sign of China's ambitions to build up its domestic semiconductor capabilities and reduce its reliance on foreign suppliers.
Exactly. Of course, it's not all smooth sailing. Saqp's rapid rise and China's broader semiconductor ambitions haven't gone unnoticed. In December 2024, Saqp was added to the U.S. Department of Commerce's Entity List.
The Entity List, that's a pretty big deal. What does that actually mean in practical terms for a company like Saqp?
Being on the Entity List essentially means that Saqp faces restrictions on its ability to access certain technologies and components that originate in the U.S. That can have a real impact on their supply chains, making it more difficult to source the equipment, software, and materials they need to keep developing and manufacturing their products.
A significant hurdle, for
Okay.
sure. So stepping back a bit and looking at the bigger picture, what's your take on Saqp's rapid growth and these technological advancements? Where do they fit into the overall global semiconductor landscape?
Well, I think Saqp's emergence is a clear indication of China's strategic focus on developing its own domestic semiconductor industry and reducing its dependence on foreign technology. Their rapid progress, particularly in areas like SAQP that push the boundaries of what's possible with existing lithography technology, is pretty remarkable.
It's a reminder that the semiconductor landscape is constantly evolving. So to recap, we've got this relatively young company, Saqp, that's rapidly established itself with this really broad scope, covering everything from research and development to production and sales. They have close ties to Huawei, sharing expertise and technology. Their SAQP patent seems to be a game changer, potentially allowing them to achieve near EUV manufacturing capabilities without actually needing EUV. They made a big splash at SEMICON China, showcasing a comprehensive suite of manufacturing tools, showing that they're serious about competing with the big players. But they're also facing challenges, like being added to the U.S. Entity List, which could impact their access to certain technologies.
Yeah, they're definitely a company to watch. They're navigating a complex landscape, but they've made some impressive strides in a very short time.
And it'll be fascinating to see what they come up with next, what future innovations they might bring to the table. Could they push DUV-based patterning even further? Might they find new ways to overcome the limitations imposed by the Entity List? There are a lot of possibilities, and their progress could have ripple effects throughout the entire semiconductor industry. It really makes you think about the future of this crucial sector and the global competition that's playing out within it.
Absolutely. It's a space where innovation is relentless, and Saqp is right there in the thick of it.
Thanks for taking the time to break all this down. This has been a really insightful look at a company that's poised to shake things up.
My pleasure. Always happy to discuss this fascinating stuff.
And for our listeners, keep an eye on Saqp. I have a feeling we'll be hearing a lot more from them in the coming years.